Hello, and welcome back to the last installment of our summer series of Technically Speaking, which we focused on a lot of the decisions you can make and levers you can pull for the performance of your application. We want it to be as fast as possible and also balance the needs of your project. In our series, we've looked at 6 different aspects of Unqork applications. And today, as I said, it's our last installment. We have Noor joining us to look at all the ways module size and scope is going to impact the performance of your application. Noor, please introduce yourself to the viewers.
I appreciate Dara for giving me the opportunity. So my name is Noor Hajyani. I'm with Unqork for roughly about 3 years now, and fulfilling the responsibility as a senior director for solutions architecture. And we have gone through a lot of applications, build up and learn a lot of lessons over the last 3 years, and find out how we can fine tune an application that we need to deliver. So, and that I believe so. We had worked on multiple of those projects where we have fine tuned a lot of applications, a lot of modules, a lot of routines that's one behind the scene. So glad to be here to talk about a lot of those experiences that we have sometimes shared together and sometimes on our own. But glad to be here, and we're looking forward to talk through and explain our viewers what it means by modularity in Unqork and how it impacts the performance and how to control the size and the scope of the application.
And Noor, as we were prepping for this, we talked a lot about modularity.
Mm-hmm.
Can we make sure that everyone's on the same page? Because I think most industries talk about modularity and reusability, about what we mean when we talk about modularity for Unqork.
So think it from a perspective of a blueprint of any design kind of thing, right? What it means a module is about. A module is about doing and fulfilling a responsibility for user interaction, maybe getting some of the data that we need to put it out there, or just an API call. So think modularity as a user action based or unit of work, and think it in its own entirety, what responsibility that module is supposed to put it out there, breaking it apart into digestible, manageable pieces helps application more manageable, more maintainable, as well as the performance of it as well. So we can fine tune where the problem area might be, or if the workload or the scenarios might have changed and how to optimize for it. So in a nutshell, modularity, if we look at the schematics of a building design or something, you start from a floor design to, okay, where the wiring is going to go. You look module by module to understand what it means when you're architecting an application. And it helps engineers to kind of follow that routine to make sure that not one piece is too much dependent on another, but still it's a good exchange of responsibilities between those modules, and it works as a whole unit or a whole building or a whole construction project if you need to look into that kind of a scenario.
Speaking to my civil engineering heart there, you knew what example to go with. And I think you touched on this briefly, but maybe let's be more direct with it. Mm-hmm. Why should we consider modularity when we're building, and how can we visualize it? Right?
Yes.
I know you talked floor plans, but not everyone loves construction like I do.
Yeah. So the slide that I prepared, and I wanted to keep it very simple, very straightforward. Doesn't matter you're looking into a codeless architecture or a for code. I come from a lot of coding background in my whole life, but it helps when I'm trying to explain to, let's say, a 90-year-old, 18-year-old web developers designing and starting the journey of, hey, web development, what it means by an application, a web application, what the basic common pieces of a web application architecture is all about. So if you look at any web application, you have a client browser that consumes that application. You have a web server that throws the bits and bytes of that application, meaning the HTML, the JavaScript files, some content around images and videos and whatever that might be. A database that helps push the data out to those web servers. There are API gateways and other CDNs and file stores that we kind of look into an overall architecture of an enterprise architecture of a web application. But if I wanted to boil it down into like 3 basic constructs, it's a web application, a web server, and some data coming from the third tier or an n-tier architecture. And if we can control the data that's moving between these 3 nodes, that gives you an optimized application. The only aspect that we cannot control is the client browser. We don't know what kind of client browser a user might be using. It could be an iPhone 5 they might be using and trying to consume over a 3G network. We cannot control it. But the pieces that we can control is how much data we are pulling from our database, right? And how much data our web servers needs to churn and in return produce a set of HTML code, JavaScript code, some content like images files, and push it down to a pipe. That pipe, again, we cannot control. Different ISPs has different speeds. Even in continental US, you will find dial-up connections still running, and some has a gigabit of fiber internet, right? But we cannot control that. Our job as an architect, as an engineer, is to make sure that we control what we're throwing out from our web server to the client browser. Could it be just the data? Could it be the code around it? And make the experience more digestible for a browser that may or may not get up to handle it, right? So that's how I see a web application. Now, if you look into the second aspect in the next slide of that how Unqork fits in this picture, right? Unqork, same way. It has a database which has our codeless definitions for all the modules, for our workflows, the application data that sometimes we decide that we store on Unqork or might be coming from a third-party APIs and stuff like those. But Unqork Runtime Engine, what it does beautifully, it mashes all those things together without writing a single line of code. But we have to pay attention to how we modularize that and put it out on the wire for the client browser to consume. And when I say that client browser to consume, remember, Unqork being a web application, a single page application architecture, all it does, it's once the Unqork application engine is loaded up, all we're looking into is to get the module definitions, the data that we need to present to the user, and make sure that what exactly the user needs to interact with, what exactly the user needs on the browser, only those pieces are being put on the wire for the client browser to consume. And if I want to expand a little bit more in the next slide, I'll tell exactly, if you look at the module definitions, right? And understanding that, look, in a codeless engine, what happens is the 5 key aspects that I'm looking into, right? The authentication happens, which does not require data. It's all authentication. Most of the authentication in any web application runs the same way. But the module definition, which we kind of pioneered as Unqork, that we are democratizing the code itself as a data in our codeless architecture definitions, that comes from database. The import of a module, if a module is importing more modules, guess what? That's also coming from database. And then the actual data retrieval. So if we can fine tune these 3 light blue shaded areas of the application, you have a performant application. Our codeless engine runs much better because we are kind of putting it into a chunk size that a module needs to, and it's fulfilling that user requirement. So that's the whole reason why modularity is that important, to pay attention to exactly what that module is supposed to do. In a classic web application scenarios, is called single responsibility principle. What the responsibility of that module should be, and when we are designing it, when we are looking into from our sprint zeros, when we are putting the stories out there, when we take let's say an epic and break it down into stories, we need to think through what those module responsibilities are, and then assist our engineers, assist our creators to think it that way as an architect as well, and our senior engineers as well, to kind of look into and say, okay, what exactly a particular module in this whole grand scheme of the application is trying to do, and what the responsibility is, and try to encapsulate that piece as one modular aspect that is, again, more manageable, more maintainable as we move forward. And then of course, based on the size of that module, it is much more performant for everyone to consume, not just the Unqork servers, but from the server to the client. When we push that module definition out to the client is happy because now you are just sending only those pieces of, or those bytes that matter the user to interact with.
That's great. So how We talked a little bit about how our principles in no code fit into general software, but
Mhm.
are there some things that we should be aware of when we're thinking about these that are specific to Unqork?
Yeah, so in the Unqork world, understand that if I have a data workflow, and data workflow is all about massaging the data, right? And trying to make sure that the data is available for a grid or maybe a graph component or maybe a chart component. If that data that I'm trying to pass it to the data workflow, if I'm retrieving that data without the conditions applied to it, and I'm retrieving too much and trying to filter in the data workflow. Now, what you are doing is you're asking the database to give you a lot more data onto the Unqork servers, and then trying to parse through that data and massage the data that can be consumed. And at times, we have seen that sometimes we pass that data all the way down to the browser, and then let the browser decide what to show. That's not a good design, right? We have to pay attention that there is no magic sauce happening. It's things that are the way that application is designed, that you need to filter that data out. The data that you want to push it out to the client is what you are retrieving from the database. It makes your application less chatty, meaning that there's less data being back and forth between the database and the Unqork servers, and try to make sure that not too much data is getting leaked into the client side, because that comes again with a security premise as well, that hey, maybe the client should not see all those data as well, right? So have to pay attention not from the performance perspective but from the security perspective. Another piece that we have seen, that if I can take this whole data massaging piece and put it into maybe a separate API that furnishes that data directly to the client browser, then I take that whole responsibility of that massaging the data and preparing the data and put it on the Unqork server, which is way more powerful and scalable than a client browser, right? It gives that the idea, and in a classic model view controller way of thinking of a web application, if you are working with the data, meaning the model, and your controller is a client side, is a server side API, or what we call our remote execute modules in the Unqork context, if that gives me the data to the presentation layer, to the view, it helps think it that way, that you are passing only the data that one specific control that client is interacting with is looking for, not everything, and then let the browser decide what needs to be shown and have tons of logic on the client side of the application, and pushing and showing that data. So that is what we need to pay attention to, and it's universal. It's not just Unqork. You can look into other applications in Angular or in React. Those principles needs to be followed, else you have an application which is very heavy, very demanding on the client browsers. It takes a lot of memory in memory for the browsers, and slowly but surely that makes the whole application perform slow, and the user session becomes too slow after that.
Absolutely. And we'll give a little shout out to Brad Kelly, who did a session with us last week all about those decisions on screen rendering.
Mm-hmm.
So if you're needing more details on how to do that, go check that out. It's up on our YouTube as well.
Cool.
And I know we talked a little bit about screen rendering. We talked a little bit about security in there.
Mm-hmm.
What are some of the choices that we can make when it comes to modularity, right? Whether they're rendering or on our back end.
Yeah, so understand, if you have a large application where we are using, let's say, workflows, right? Make sure that your workflows are designed to be performant. When I say that, a workflow, most of our application, when they are going to workflow, they are doing some kind of a navigation. Understand that in that application, if you have a common header that is repeated on every screen, you may have a side panel that is repeated on the same screen. You may have a footer. Take that and put into a common header and a footer. Because what happens is that you're not computing the permissions on those multiple times, right? If you're importing that on every screen, it costs on the server side to make sure that being SOC compliant and make sure that the security is guarded. We want to make sure that all those permissions are calculated before the user can see the data. And then what happens is that you are asking for every screen to compute the data for that header. We don't have to do that if we use the inbuilt that Unqork provides, a very out of the box way of saying, hey, this module acts as my header. And you can throw in the side panel in that header as well if you want to, and do some CSS magic around it. And then also your footer needs to be common, right? And what you do is, like, if your module has, let's say, 20 screens, rather than importing those modules 20 times, meaning that your module count goes to 40 plus those 20 screens, like 60, now you're reducing it to 20 screens for 20 modules for 20 screens, and then one for header and one for footer. So you have 22 modules to worry about in the whole application architecture, rather than importing it multiple times. So that reduces a lot of cost on the server side. I know Unqork servers are powerful, they scale well, but again, the more we can pay attention to those basic stuff, it helps application optimize the performance, the security compute, and less chatty between the server and the database itself. So that's one part of it. And I'll give you another example that comes in a lot of our applications, like most of the modern applications today show the dashboard, right? Your dashboard has a grid, some controls to filter, like drop down, maybe a text box, and then some charts and something, maybe a bar graph or something for KPIs, right? Now, if you think of that as one module, if you break it down into its modularity, what it is, it's a grid that's responsible for displaying the data. Then we have to make sure that the data that we are displaying on that page one is only the data that page one needs it, right? Not trying to pull tons of data and push it to the client browser. Although our grids are powerful enough that can handle thousands and thousands of rows to display, but maybe the client browser is a old Windows machine that does not scale well, right? So then the application performance gets a hit because the user does not have that much bandwidth or memory to consume that data immediately. So the idea is to break it down into chunks of the data and understand that we have good pagination options in our grids and use those. Now, coming to the KPI part of it, the chart, the data that we need to show, of course, that needs to account for the whole search set. I'm not saying, hey, I need only 50 records for page one here that I can get for the grid. I'm looking that maybe there are 3,500 records and the KPIs are computed on that. Now we can take advantage of our dynamic refresh, that the module computes everything on the server side, get the data, get the chart that needs to be shown, and dynamically inject that into the user screen. And your dynamic refresh, which is a very big enhancement that we have pushed it out and been liked with by so many of our clients, helps us in a codeless way to push that module out there, which is computed by all the servers, resources, and the bells and whistles that we have on the server, and put just that graph component, the HTML around it, the CSS, and maybe some graphics around it, only those bytes, which is like few bytes here and there, rather than churning all the data and pushing that data onto the client browser. We use that dynamic refresh to just render that one image and put it out there dynamically, and the user gets the most of the optimized experience, that rather than pushing sometimes megs worth of data onto the client browser, we are pushing a few KBs, and it makes the user experience so much better, and they enjoy it because now the application, they can work faster, they can click through faster, multiple records, and jump from one page to another. The KPI stays there. All those good bells and whistles that we push it out there when we are designing these applications helps us kind of get that performant user experience out there.
Amazing. And just to kind of wrap up, I know we've kind of traveled from the very beginning of what is modularity all the way down to what are the pieces that we do specifically in Unqork. Are there any rules of thumb that our app engineers or developers in Unqork should really be thinking about if they're planning for modularity and performance every time?
Yeah, so basic principles, and it's in one of my last slides. Sorry, that slide's gone away, but I'm pretty sure that we can pull it back. In the last slide, we look into some of those basic things, right? That when we are trying to design for performance, we look into what the responsibility of that module is about, right? We follow a single responsibility principle, saying, hey, this module that I'm looking for is showing a dashboard, and from the user perspective, I can put a grid out there and maybe 2 more panels that dynamically refreshes some KPIs. That's it. Now, the module that is supposed to give me the data for that grid. The responsibility of that API module is to make sure what parameters am I passing. Is it the filters that I'm applying? Is it the page size and the page number that the user is trying to browse into? It takes all that input in accommodation and gives me the data that the user needs to see for their action. That's the responsibility of that module is. And then the KPI module that we talked about, that hey, as we change our filters, okay, pass the params to that dynamic refresh modules to render the new bar chart or new pie chart, whatever you want to display there. So break it into that functional pieces. Think it like the responsibility of when you divvy up the home chores between yourself and your spouse. Okay, I'm doing laundry today, you're doing trash today. You break those responsibilities in that fashion and saying, oh, this module itself is not one module. It has different components, and the modularity of that module, of a dashboard module, is okay, I need to show data in the grid and some KPIs to be computed, and how I can best engineer each of those using the Unqork out-of-the-box features to get the best result out for our users. So that's one piece, right? And then again, the second rule of thumb that I put it out there is that don't over-design it. Don't try to break things that you are not reusing. I've seen multiple times in an application that just so that multiple teams can work, we break the module into sub-modules and try to import it, although that import is not being reused multiple times. It's not that we talked about header and footer that can be reused, but that has a better way of incorporating into our workflow, right? We don't want to kind of import it multiple times. But another piece I've seen sometimes that, hey, there's a unique kind of social security component that we need to put it out there. Should I import it multiple times or make a snippet and drop it every time? Those are some of the decisions, right? So don't over-design pieces where it does not need a true import. A true import is where you have a module which can be reused multiple times. Like at least I give it a say, hey, if it's being imported more than 3 times, or if that functionality is common on more than 3 user modules, import it. Else there might be something. If it's a nuance here, I'm trying to over design, I'm trying to over parameterize some module, it means that I'm pushing it to the limit. So keep it simple. And then the last important thing we talked about, query the data that you need to show. If I have 5,000 records in the system and I'm only showing the first page for a user on a grid, which means that I need to show only 50 records, maybe or 100 records, if the page size user has set to 100, I should pull 100 records, not all 5,000, and then dump it on the browser, and then the browser decide, okay, what the user wants to see. That is, to me, is a violation of those simple principles that we are pushing too much on the browser. And doesn't matter codeless or any other architecture you talk about, those are the no-nos, right? So when we talk with a lot of our DIY clients and our SI partners, those are some of those pieces that we talk about and say, look, you need to pull the data that is meant for that screen. Don't push too many things in a web application, or web applications being stateless. When you try to push too much data and you are now trying to maintain the state of the application, guess what? The browser starts consuming a lot of memory on the user machines, and the application, despite our best effort, starts behaving slower after one after another clicks, right? So we want to make sure that we don't push too much things out there in that, right? And again, we talked about reusability. Has to be a true reusability case. If you are trying to divide work between multiple teams, yeah, we have version control systems now. Use that. You can have your own copy running, and when you are ready to merge that, use that pieces rather than saying, hey, since I have 3 guys working on the same module, let's break this module into 3 different modules that can be imported so 3 people can work together. That's not the way to work. Our work in a traditional software development is the same class or same object that people are trying to work into, and they all checking their code. That code gets pushed out and say, hey, this is what. Same with the codeless definition. Your codeless definition can be merged by multiple people working, multiple resources working at the same time. And if there are conflicts, you can resolve it. Someone can raise the merge request and stuff like those, and someone can review it and then accept that and push it out into staging and then all towards the QA pieces. So think it from that perspective. Don't overthink, don't overuse some of those pieces that we have out of the platform, And those are some of the guardrails that I usually talk about with a lot of our clients as well.
Those are great rules of thumb. Remember what the purpose of your module is. If it's not imported 3 times, it's not worth breaking apart on its own. And lastly, just making sure that you're pulling back only the data that you need, not pulling everything back when you're querying. Thank you again to Noor. It was great having you. We will be back with Technically Speaking with a pumpkin spiced theme fall session after Labor Day. Great to have everyone.
Thank you, Dara. Thank you, everyone.